Hello, my name is David, Masters of Science, Data Science, Leeds Beckett University, and I'm going to make my presentation titled The Determinants of Life Expectancy in a Country. In this presentation, life expectancy is a target or dependent variable, and the life expectancy of a country is defined as the average death age of people living in that country. This brings us to the aim and objectives of this study. The aim was to identify factors that affect life expectancy of a given country and also to test the significance of machine learning in the prediction of life expectancy. In the process, I have built, tested, and trained several machine learning models using machine learning techniques like single linear regression, multiple linear regression, multiple layered perceptron MLP for classification and regression, decision trees, and I've gone further to apply deep learning. Now this brings us to the question, what factors are being considered in this study? The factors being considered in this study are carbon monoxide emission, population, forest area, electric power consumption, GDP per capita, individuals using the internet, which I find really interesting, military expenditure, the use of basic drinking water service, the practice of open defecation, obesity among adults, beer consumption. So what we do in this study is find out how do these factors correlate with life expectancy, and if they do, in what way do they correlate with life expectancy? Would an increase in this factor lead to a decrease in life expectancy, or would an increase in this factor lead to an increase in life expectancy? So why carry out this research? Why is this research important? What is my rationale for this study? Life expectancy is a very important economic index. You could use life expectancy to tell if a country is performing well. As an individual, you could use, as an individual and as a citizen, you could use life expectancy to know if the government which you have elected into power is performing well. And the government can also use life expectancy to help to know what amount of resources should be allocated to the healthcare sector. And you can also tell if your country is aligned to the United is in line with the United Nations Sustainable Development Goals. I will emphasize on promoting healthy lives for all ages, which is the third of the 17 SDGs. Okay, the data set was retrieved from Kaggle, which is a repository for a community for data scientists, and originally it was hosted on World Bank's data repository. The dataset contained about 1,904 rows. For my analysis, I used Python for data science. I cleansed and normalized the dataset to improve correlation test and to improve the responsiveness of the machine learning techniques. I also ensured the data was complete, and I hot encoded target variable to enable me apply machine learning classification techniques. So this is an overview of the libraries I used in Python. Pandas for statistical analysis, NumPy is just to support data manipulation. sklearn, the machine learning library, contains all the machine learning functions. TensorFlow was for deep learning, and Seaborn and Matplotlib were used for plotting the graphs. I have used df.describe to give a summary of the data sets, and we can see that the mean of the population is about the mean life expectancy of the population is about 70 years. Standard deviation, which indicates the variation from the mean, it's about 8.4, and we can see figures for 25% percentile and 75 percentile. Over here, we can see that 25% of the population have life expectancy below 66 years, which is quite alarming. The histogram visualizes the skewness of the data for the dependent and independent variables. We can see life expectancy, people using the least basic drinking water service skewed to the left, and then we have population, carbon monoxide emission, electric power consumption, military expenditure, people practicing open defecation, and beer consumption, all skewed to the right. And we have forest area and obesity among adults as bimodal, and then we have health expenditure as normally distributed. Visualizing the data with a stacked bar chart, I have grouped the data by continents, and I have assigned different color codes to the dependent and independent variables. So taking a look at the continent Africa and comparing it with every other continent on the stack bar chart, you will notice that Africa is a continent characterized by low life expectancy. So let us see the features of Africa. Africa has a very poor GDP, and Africa also has a larger number of people practicing open defecation. Africa is also characterized by poor access to basic drinking water service and also a lower number of people having access to the internet. So when we compare these features in other countries, we see that in other continents, we see that other continents are doing fine. And we can assume that these features mentioned are definitely contributing to Africa's low life expectancy. So for other features like CO emission, beer consumption, and obesity level, they might be an indication of another variable that affects Africa's life expectancy. So in terms of when I mean another variable, a variable like GDP, because when GDP is poor, then definitely the country is not industrialized and there are no jobs. People don't have money. People can't buy foods, fatty foods, and stuff like that. And then a country that is not industrialized definitely will not have a lot of CO2, carbon monoxide emission. And also you can see Africa is also indulging in a lot of military expenditure, considerate level of military expenditure. It's probably that during this period, there have been a lot of like social unrest and stuff like that. Okay. So the time series indicates that life expectancy is will tend to increase as we project into the future. People will tend to live longer, definitely due to enhanced technology and also the development of cure to various diseases. The correlation heat map tells us how the target variable life expectancy interacts with the independent variable by giving us a summary of the correlation coefficients. So we could see the correlation coefficients of life expectancy with all the independent variables. From the t-test results using a confidence level of 95%, the t-test result indicated that population and forest area did not in any way correlate with life expectancy. Since they had p-values greater than 0, they did not in any way impact life expectancy and they were eliminated from the analysis. So all other features correlated with life expectancy. With the scatter plots and a line of best fit, I have just shown how one of the highest correlating independent feature, which is basic drinking water service, I have shown how basic drinking water service interacts with life expectancy on this with the aid of this graph. For machine learning, only columns that passed the t-test were used. I dropped the population and the forest area because they do not correlate with life expectancy. And the summary of my analysis using machine learning, you see that electric power consumption did not work fine with any of the machine learning techniques. Then we can see that for single linear regression, only basic drinking water service performed well, returning a very low root mean square error and very high coefficient of determination. And basically, this table gives you an overview of how of what features perform fine with the respective machine learning models. Evaluating the logistics regression, we had a very good accuracy score and a very good AUC. You can see 95%, and the confusion matrix was quite impressive. We have a lot of true positives and true negatives. The model worked very good. For the two classification techniques, MLP classification and decision trees, electric power consumption did not perform fine with the model, but other features that correlated, performed very okay with the model. It is important to know that decision trees are susceptible to overfitting. So we do not know if decision trees might have, overfitted like quite a number of columns here. But MLP classification is definitely a very good technique to be applied in prediction of life expectancy. So this is the image of the decision tree, and you can see the confusion matrix of this decision tree indicates that the decision tree performed very well. You can see we have a good number of true positives and true negatives. For deep learning, all the features that work with the classification techniques were passed into the deep learning model. The model returned an accuracy of 89%. Deep learning was built with TensorFlow, and I recommend deep learning for the prediction of life expectancy. From my findings, I can confidently say that population and forest area do not in any way impact life expectancy. However, for electric power consumption, we were able to see a weak positive correlation. Unfortunately, electric power consumption did not work with any of the machine learning models. It might be unwise for us to discard that feature because we might want to consider what type of electric power consumption was actually consumed in this country, in these countries, because there are two types of electric power consumption: renewable electric power consumption and fossil fuel. That brings us to the next research question on the next slide. Okay, here we go. To improve life expectancy, we need to create awareness for the need for properly sanitized environments. Governments should provide basic drinking water services for their citizens and improve the healthcare by channeling enough budgeting resources, and also implement policies that lower emissions levels and improve the economic health of their respective countries. So thank you so much for following. My name is David Oku. In the description of this video, you'll find the links to the dataset used in the analysis of this study. You'll also find the links to my codes on Google Colabs, and all other relevant links are in the description of this video. Don't forget to hit the like button if you find this really exciting, and don't forget to subscribe to my channel.